Ear. We all know that ear is an organ that detects sound. But did you know our ears also help in balancing our body? That is, it helps to maintain upright posture and move without falling over. Human ear can hear sounds of frequencies ranging from 20 Hz to 20,000 Hz. But only young people are able to hear this full range. Most of the sounds that we hear fall within 500 Hz to 5000 Hz. The intensity of sound is measured in decibels. What happens to the sound that enters our ears? Sound waves in the air are transmitted as vibrations into the ear. These physical vibrations are detected and converted into electrical signals. Then, the nerves carry these electrical signals to the brain, where they are interpreted. The interpreted messages allow us to become aware of sounds such as speech and music. First, let us learn the different parts of ear. The structure of ear can be divided into 3 parts. They are outer ear, middle ear, and inner ear. The outer ear includes pinna, external auditory meatus, and outer layer of the eardrum, which is also known as tympanic membrane. The middle ear is an air-filled cavity behind the tympanic membrane. It includes 3 bones, namely malleus, incus, and stapes. Of these, malleus is attached to the tympanic membrane, stapes is attached to the membranous oval window, and incus joins malleus and stapes. An oval window is a connective tissue located at the end of middle ear and the beginning of inner ear. The inner ear is also called labyrinth. It includes cochlea and vestibule. The cochlear portion of the labyrinth is a tubule that is coiled 2.75 times. Throughout its length, the cochlea is divided into 3 compartments by 2 membranes. They are basilar membrane and Reissner's membrane. The middle compartment is called scala media. It contains endolymph. The other 2 compartments are scala vestibule and scala tympani. It contains perilymph. The basilar membrane gives rise to 4 rows of hair cells. On the basilar membrane, organ of Corti is located. The organ of Corti contains auditory receptors. Okay, now let's travel through the ear and learn the mechanism of hearing. Initially, the sound waves enter the external auditory meatus. Then, it passes through the external eustachian canal and fall on the tympanic membrane. This causes the tympanic membrane to vibrate. These vibrations are then transmitted to the middle ear. The tympanic membrane has an area of 90 mm square and the foot plate of the stapes has an area of 3.2 mm square. So, in the middle ear, the lever system formed by the malleus, incus, and stapes multiplies the vibrating force 1.3 times. These vibrations are then transmitted to the oval window. When the foot plate of the stapes move, it sets up a series of waves in the perilymph of the scala vestibule. This in turn vibrates the vestibular membrane and hence the endolymph in the scala media. These waves deflect the Reissner's membrane, which in turn produces disturbances in the basilar membrane. This bends the hairs of hair cells in the organ of Corti. This develops action potentials in the related nerve fibers. These action potentials are then transmitted along the auditory nerve. The site of maximum distortion in the organ of Corti is determined by the frequency of sound. For high-pitched sounds, the maximum height of the waves is near the base of the cochlea, and for low-pitched sounds, it is near the apex. The extent of distortion is determined by the loudness of the sound. Interpretation of these impulses is made in the auditory cortex. Let's have a quick recap.